All right, so we just did a preview of what the tree diagram looks like. And now we're gonna go ahead and further practice it, okay? All right, before we get started, some things got cut off when I copied it. So this one should be, the spinner is spun and the coin is tossed. List all the outcomes. How many are there? This is the probability of getting an A and a T, which would be tails. Probably getting an A and a T. Okay, so remember if you have the P outside of the parentheses, you read it as probability of getting an A or a T or whatever it has. All right, so this is spinner 1. We're gonna always start with our first event. So the probability on here, there's 3 different things, right? So we have A, B, C. That's what's in my first spinner. So this is my first event here. All right, so what's the probability of getting, what do you get when you flip a coin? Heads or tails, right? So here we're gonna do heads and tails, heads and tails, heads and tails. All that says, if I do this spinner, I could get an A, B, or C, and if I flip a coin, I can get a heads or tails. And now we're just gonna write outcomes. So we're gonna go left to right, so I can get a or a head, A or a tail, B and a head, B and a tail. I can get a C and a head, or a C and a tail. Those are the only outcomes I can get. So how many outcomes are there? 6. Okay, so 6 is going to be my denominator. But this asked us, what's the probability of getting an A and a tail? How many are A and a tail? 1. So 1 out of 6 are exactly A and a tail. All right, example 2. You roll a dice and then the spinner lists all the outcomes. How many possible outcomes? All right, here I'm gonna make a change. Instead of 3 and a C, I'm gonna make it B and a C. We're gonna make it a little more difficult on ourselves here. Also too, the copier is in desperate need of some ink. So this is an A, okay, B, C, and D. And this one's A, B, and C. You can just go ahead and fill those in. On my first event, on my first spinner, I can get an A, B, C, or D. So I'm going to list A, B, C, or D. And on this second spinner, I can get an A, B, or C. So you're here A, B, or C. So I can get an A, or I could get an A and an A and a B, or I can get an A and a C. Okay? Or I could spin it, I could get a B. I could get a B and an A B and a C, or B and a B and a B and a C. Same thing with C. I could spin a C on my first spinner, and I could get an A, B, or C on my second spinner. Same thing with D. Could get a D on this one, and an A, B, or C on my second spinner. And I'm just going to list my outcomes. So I get an A and an A and a B, A and a C, B and an A, B and a B, or a B and a C. Or I get a C and an A, C and a B, or a C and a C, or a D and an A, D and a B, or a D and a C. Those are all the outcomes I can get from these two spinners. Okay? So I'm going to count them out. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. But then I have to see what's the probability of getting a B and a C. Okay? So I got to look here. Here's a B and a C. Any more? Nope. So how many? 1 out of 2. 1 out of 12. So I get a probability of getting a B and a C is 1 out of 12 times, or 1/12. All right, the third example. You toss a penny, then a dime, then a quarter. This will give you a 3-stage, 8-branch tree. All right, so what coin is first? Penny. So I'm gonna write penny. And on a penny, if I flip it, what can I get? 2 sides of a penny. What can I get? Heads and tails. And then I'm going to flip my dime. Same thing. I can get a heads and a tails, or a head and a tails. Then I got to flip a quarter. Then again, I can get a heads or a tails. Heads and tails. Heads and tails. Heads and tails. So there's my penny, my dime, and my quarter. So I'm just making a tree. I'm taking branches off of my trees. All right, so let's list the outcomes. We can get a heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So the directions said that we can get a 3-stage, 8-branch tree. So here's my 1 stage, 2 stage, 3 stage, and I get 8 branches. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So how many outcomes do I have? I have 8. 8 outcomes. I have 8 outcomes. All right, we got it? We need another second. All right, flip it over. I go ahead and try that practice one. Use the front as your example. Okay, you might have to go flip back over a couple times, okay? But it says 2 spinners are spun. Draw a tree diagram showing all the outcomes. Just draw a tree diagram real quick. We'll see how we go. Not the first one. I'm gonna help you with the second one. I'm gonna tell you what it is. Yeah, just do the first one.
Which says 2 spinners are spun.
What?
The one that says 2 spinners are spun.
Yeah, I want you to do a tree diagram for that one. So, Randy moved then? Somebody try? Okay. Alright, I'm just checking because I haven't seen him. Alright, does anybody have this one? Alrighty. So we have 2 spinners. So what might happen on my first event? I could get a what? A and a B. What could I get on my second event?
A, B, C. A, B, C. The third one, A, A.
There's no third one.
Oh.
You only have 2, right? So let's go ahead and do our outcomes. We can get an AA, AB,
Yeah.
AC.
B, A, B, B, B.
Okay, those are our outcomes. All right, we're going to use those outcomes to answer the questions down here for the practice follow-up here, but I need to tell you what it is. So this one's going to be the probability of getting an A and a C. I'm going to change this one to probability of getting a B and an A. This would be the probability of letters the same. And this is the probability of letters different. So use the outcome that we have up here to answer these questions. So look at these to answer these. That's what I'm saying. All right, what's the probability of getting an A or a C? Or A and a C? What's the probability of getting an A and a C?
1 out of 6.
1 out of 6. Probably getting a B and an A.
1 out of 6.
Probably the letters the same.
2 out of 6.
Sure? 1. Let's see. Yep, 2 out of 6. Which would be what?
1 half.
1 out of.
I mean, 1 third.
Perfect. All right, different?
4 out of 6.
Yep.
Which should be 2 thirds.
2/3. Perfect. Questions about that? All we did was we went back to our outcomes up here to answer these questions. Okay? All right, this one. This is something that you might see soon. Okay, remember I told you that you might see a lot of tree diagrams when it talks about food? This one's drink and food. All right? So the after-school Tiger Club meeting, there were 4 drinks you could choose from: orange juice, Coke, Dr. Pepper, and water. There were 3 snacks you could choose from: peanuts, fruit, and cookies. Each student may only have 1 drink and 1 snack. Create a tree diagram showing all possible choices. How many possible outcomes? All right, so what are you going to choose for your first event? Drink, right?
Yeah.
All right, so what are the drinks? Let's put them in order. OJ, Coke, Dr. P, and water. I'm going to do H2O. H2O. What? Hey? Dr. Pepper. Alright, so with each one of these, they have a choice of a snack. So they could get OJ or orange juice. What else could they get? Peanuts, fruit, and cookies, right? So they could have orange juice with peanuts, orange juice with fruit, or orange juice with a cookie. Or they could have a Coke with peanuts, fruit, and cookies. Or they could have Dr. Pepper with peanuts, fruit, and cookie. Or they could have water with peanuts, fruit, or cookie. So our outcomes, they could have orange juice with peanuts, orange juice with fruit, orange juice with cookie. I'm just using letters for these so I don't have to write them all out. Or it could have Coke with peanuts, Coke with fruit, or Coke with cookie. They could have Dr. Pepper with peanuts, Dr. Pepper with fruit, or Dr. Pepper with cookie. Or they could have, I'm going to use W for water, water with peanuts, water with fruit, or water with cookie. So how many possible outcomes do we have? Twelve possible outcomes. So there's 12 possible outcomes for the drink and the snack. Okay? So can you see a way you could use multiplication to find the number of possible choices above? What could we do? Instead of doing this, there's another way. Remember, I'm showing you multiple ways to solve compound probability. What could you do?
Multiply 4 by 3.
Multiply your drinks, which are 4. You have 4 options for drinks, times 3 options for snack, gives me 12. So this is drink, snack, outcomes. Okay? Drink, snack, and outcomes. We just multiply the number of drinks by the number of snacks gives us the number of possible outcomes. Questions with that one? No? Nothing? Why are we getting like tons of emails or whatever feedback?
Oh yeah, it's one of the TS changes. For class.
No, you're not leaving the room. All right, go to the right side. All right. A combination is a collection of things in which the order does not matter. Okay? Group, committee, sample. So you're making a sandwich. How many different combinations of 2 ingredients can you make with cheese, mayo, and ham? So cheese, mayo, cheese, ham, or mayo, ham. So there would be 3, right? So if I have 2 ingredients, guys, seriously? So I have 2 ingredients, okay, and I have 3 options. So like we just said before with multiplication, we could do 2 times what? 3, okay? All right. So how many different combinations of people can be chosen to work on a special project from a group of 7 people? So let's go ahead and use letters to represent people. All right, A, B, C, D, E, F, G. That's 7. So that's 7 people. All right, so I could do, they want a set of how many different people? 3, right? So I could do what? A, B, C, A, B, D, A, B, E, A, B, F, A, B, G, right?
Yep.
Then I could go and I could do, I did all the ABs, so I could do A, what could I do now? A, C, D, A, C, E, A, C, F, and A, C, G. And just work them away from left to right. Then I could do, move on to the D's, A, D, E, A, D, F, and A, D, G. I'm not even on the Asia. What? Can you speak so I can hear you, please? Okay. When you write, do you put your fingers on the paper?
Yeah.
I gotta hold the paper still. Just give me a second. All right. So then I have A, E, F, A, E, G, B, C, D, B, C, E, B, C, F, B, C, G, B, D, E, B, D, F, B, D, G. B, E, F, B, E, G, B, F, G, C, D, E, C, D, F, C, D, G, C, E, F, C, E, G, C, F, G, D, E, F, D, E, G, D, F, G, and E, P, G.
EPG?
Mm-hmm. Is that a fun way to do it?
Yeah.
Takes a lot of what? Work and time, okay? So we're going to go ahead and learn ways that we don't have to go ahead and list them like this because we'll be here all day. Okay? So that's why we need to pay attention in class because this takes too much time. It works, but it'll take too much time.
Wait, what's the last one? PPG.
EFG, I think it is. Because we didn't have a P. It's an F. It's an F. Alright. Let me grab this. It's F. Sorry. Alright. We got some extra time. We got time to get a couple of these done. Alright, let's look at these. We'll just do these together because we only got a few minutes left.
We're not doing the rest.
How we're just gonna do them together?
How many of this take?
No, because guess what? We're gonna try something that's easier than just listing. That's why I was trying to prove a point. Alright guys, let's go over these. Alright. You roll a single die numbered from 1 to 6 twice. Guys, I can't talk over you. You roll a single die numbered 1 to 6 twice. What is the probability of rolling a 6 the first time and an odd number the second time? So what are we going to do? This is from yesterday. So how many on the first one, what could we have? Let's do the first event. So what is the probability of rolling a 6 the first time on a die? 1 out of 6. What's the operation we did?
Multiplication.
Okay.
That's multiplication.
And an odd number on the second.
1 out of, no, 5 out of 6.
An odd number on the second one.
3 out of 6.
3 out of 6 would also be what? 1/2. So multiply across 1 out of 12. Okay. Alright, the numbers 4 through 14 are placed in a bowl, it should be bowl, and drawn at random, then replaced after being drawn. So this is with replacement, right? Okay. What is the probability of drawing the number 14 and then a number less than 12? Alright, let's do the first one first. So the numbers 4 through 14 are placed in a bowl. So what's the probability of getting a 14?
1 out of 10.
1 out of 10. And on the second event, what's the probability of drawing a number less than 12?
2 out of 10.
Numbers are 4 through
Oh.
14. So how many are less than 12? So 12 is not included because it doesn't say. So we got 4, 5, 6, 7, 8, 9, 10, 11. So did you say 8? You did? 8 out of what?
8 out of 9.
It was with replacement.
Oh,
So I did that. So divide both by what? I divide both by 4. 0.25. Okay? Alright, so we're taking what we learned. I'm not going to talk over you. You need to pay attention, Rogelia. Alright, so what we're doing now is taking what we learned in the notes and we're applying them to what these word problems, okay? Demetria, could you do all these right now? You might want to pay attention. Alright, so the letters that form the word Mississippi are placed in a bowl. What is the probability of choosing a vowel, replacing it, and then drawing a P? Alright, so let's do one thing at a time. How many letters are in Mississippi? M-I-S-S-I-S-S-I-P-P-I. How many?
9.
How about 11? Alright. What is the probability of choosing a vowel? How many vowels do I have? 4? Is that 4 I's? Good. Alright, what's the probability of choosing it and then replacing it and then drawing a P? So I gotta put it back so my denominator stays the same. And how many P's I got? Right? Multiply across it, 8, and what's 11 times 11?
100.
Where'd you get? Okay, we can't simplify that anymore, okay? Alright, so you're gonna see a lot of these soon, okay? So just make you think about replacement and not replacement, alright? Or without replacement. Go ahead and put these notes from today in your binder. In the binder clip, Braylon, that way you're not losing them again. I didn't ask for your input, Francisco.